Assalamu alaikum everyone. Welcome to the Eduverse, a universe of learning. I hope you all are doing so well with your family, with happiness and joy. Today we are going to talk about a very key concept and important concept of the physics, that is the scalar quantities and vector quantities. And today we are going to understanding the building block of the physical quantities that is presented by the Eduverse. First of all, we should to know that what are the physical quantities. As we have discussed in our previous lectures about the physical quantities in details, here we will have only the definition. Physical quantities are the properties of the matter or energy that can be measured. The physical quantities that can be measured. In simple words, I can say that the physical quantities are those quantities that can be measured. So there are two the physical quantities are classified the physical quantities are classified into two main types, that is the scalar quantities and the vector quantities. This is because of there are some different properties that we have only the scalar quantities only have magnitudes, while the vector quantities have both magnitude and the direction as well. We will have in detail about in the upcoming slides. Scalar quantities, definition and the examples. Scalar quantities are actually those quantities that has only magnitude but no direction, that will be only described using the single number and its unit. Here we have the examples. The examples are here just to make it more clear. Let's suppose we have a mass of 5 kg. We can say that yes, a 5 kg mass, but we don't know yeah, or we cannot say that a mass in what direction, a mass in a direction. We cannot say that a mass in a direction. It's the same as for the time. The time, we cannot say that time in the east, 10 seconds in the left or something like this. Temperature 30 Celsius, we cannot say that the temperature in that direction. So it means that we do not need any direction for fully specifying them or fully telling about them. So this type of quantities we have in the physics, that we can call them a scalar quantities. While we have the another type, that is the vector quantities. The vector quantities are those quantities that has the magnitude and direction as well as specified direction. Cannot be fully described without direction. If we don't use direction with them, they will be half meaningless. Representing using arrows, we will discuss about it in the upcoming in the upcoming slides. Here we have an example. Force, if we see that force 10 Newton, like we will say force 10 Newton in what direction, means that if we don't use the direction with them, the half meaning of this of the presenting or telling about this quantity will be meaningless. So for fully meaningfully quantities of telling about the fully knowledge about these quantities, we will also use the direction. So same for the velocity, same for the acceleration. Like acceleration, we have a great example as for gravity. Sorry, means that the gravity is always directed toward ground, means that in the downward direction. For example, if we say that if we have an object falling from the air toward the earth, the falling object is always directed toward the earth, meaning in the lower direction, in the downward direction. So if we do not use the direction with the acceleration, so it will be totally meaningless. So the acceleration will always with the acceleration there will always be the direction as well, because if we don't use any direction, then that will be half meaningless. For the displacement as well, the displacement 20 meter in the north direction, 20 meter in the west direction, all that will be considered and all that should to be written with the direction. If we don't, again I'm saying that if we don't use any direction with them, that will be halfly meaningless. So the vector quantities are those which has magnitude as well as direction. Here we have key difference between the scalar and the vector quantities. Yes, we have some features will be in this column: scalar quantities properties and the vector quantities properties. Magnitude. Magnitude, yes, both has the magnitude. Scalar has magnitude, vector has magnitude, yes, but the direction, no. Scalar don't have any direction, but the vector has direction. So here will be no for the scalar and yes for the vector. Representation. The representation scalar can only be represented by a number with its unit, like the 5 of the mass with the 5 kg, time 5 seconds, speed 5 meter per second. All that will be only represented by a single number and its unit. But the vector can be represented by arrow, number and its unit. That will be the representation of the vector. The example of the vector is force, displacement as velocity as we have discussed in the previous slide. Representation of the vector. As the scalar is simply represented by a number and its unit, but the vector is not like that. Vector should to be specially treated. Like here we will have some details. How? Okay. Arrow shows the direction. Means that arrow, it shows the direction. Sorry for the my drawing because I'm little bit not. I'm more weaker in it. So let's try to try to understand it. Okay. Yes, this shows the direction of the vector. Length of the arrow shows the magnitude. Okay, this length we have of the vector of the this arrow shows the magnitude, like how much magnitude is this with the arrow. Like this one vector is smaller, this one vector is larger. So this is the magnitude. The arrow's length shows the magnitude. The directional angle shows the orientation. If we place an x-axis over here and have the angle over here, orientation angle, that will show the orientation of the vector. Notation, how it should to be notated. Vector should to be, must have to be a dark, mean that with the bold notation. A, not a simple A, but should to be a bold notation. Or we can also the vector should to be like this, arrow on its top. Here we have the A must have to be, or any vector must have to be bold or having arrow on its up on the top, and the magnitude of the vector is represented by this, having the bars on the absolute bar on the both of the side of the vector. So this is the magnitude, and also it can also be represented like this, having the same vector, arrow on its top and bars on the both sides. This is also can be the way you will need to, or you have to represent the magnitude of the vector. It is a very important thing, because if you simply write in A, no one will believe you that it's a vector, because you did a wrong notation of the vector. The vector should to be, the notation of the vector should to be either bold or having a arrow on the top of the vector. And also for the magnitude to be bold and having a bars on the both of the sides in this way or in this way. This is about the representation and notation of the vectors. Why this is this important in physics? Like why we should or why we make it different from one another, or why we have a distinguishing between the scalars and the vector quantities. For example, if we don't have any such type of distinguishing, somebody told us about find this quantity. If we don't know either it is a vector or it is a scalar, then we will also know that we will also do not know that, like what formula we should to use, either of the scalars, either of the vectors, either of the both, or something like this. So distinguishing between them, because for the direction and magnitude we will have a different formulas, and for only the magnitude we will have different formulas. If we don't distinguish between them, we will never able to point them accurately. So we distinguish them, and we have the distinguished formulas for the both of the different quantities for both of these two types, so that able us to solve the problems very accurately and precisely. Direction matters in motion, forces, field, and more. All that should to be direction should to be matters in these quantities, and in these quantities like the vector quantities. Mistaking one for the other leads to the wrong. If we have mistaking in finding about or figuring out about the scalar or vector or having formulas for them, that will lead us to the wrong answer, because we will choose the wrong formula, and that will give us the wrong answer. So have a quick recap for the today's lecture. Physical quantities are either scalar or vector. Yes, scalars are those who has only magnitude, are those quantities that has only magnitude, but the vectors are those quantities that has magnitude as well as direction. This is the main difference between them. Identify correctly to apply right formula and reasoning. Yes, as I have told you before, that if we know about them, we will use an appropriate and a correct a formula for both, and we will have a right answer. If we don't know like which formula should to use, we will have a very wrong answer, we will lead to a wrong conceptions. So this is about the today's lecture. Thanks for the watching. If it helpful for you, so you like it, and also share with your friends, because that should be beneficial for them as well. And the main thing, don't forget to subscribe this channel, because Eduverse is always be here for you to solve your problem, to solve your queries, to clear your concepts and all that. Yes, if you have any problem, if you have any confusion, if you want to give me a suggestion type, then the comment box is always open for you people. You can comment over there, or you can contact through my own or my personal email. You can contact over there, you will be responded inshallah. And thank you so much. Stay tuned, and always try to learn, not from only the books, but to acquire from the society, from everything, and always try to be the best one. Thank you so much. Allah Hafiz. Stay blessed.